Hey everybody, I'm Sean Powers. If you're following along as we're making this Linux Plus course, I'm sorry that I was not able to record for an entire week. My voice is mostly back. I'm a little bit rough sounding, but I'm going to get through this video and we'll keep training. Again, my name is Sean Powers. I'm here to help you learn everything, to do what you love, and most importantly, be kind. Now, we are covering CompTIA's Linux Plus objectives to prepare you for the exam. And specifically today, we are covering 1.2.1. Now, they don't actually break it up that way. It's actually just 1.2, this objective, but I'm going to chop it up a little bit. And we're going to cover, I kind of gerrymandered this objective, and we're going to cover all the things that I've circled in this blob here. Basically, I want to cover the general command line tools for getting around directories and stuff like that on your system. And then I want to talk about hard links and soft links or symbolic links, and do some other stuff with file metadata. Just a quick show you how it works. Now, we've covered these in the Linux Essentials course, so if I go too fast, you can please go back and watch that entire playlist. But this is pretty simple stuff. We should be able to get through this in pretty short order. If you're not familiar with my other stuff, these are just some of my comic characters. I thought after a week of being gone, they would help cheer me up. So this is Blue and Blue's dog Spot. You can check them out at mybigroundworld.com. But anyway, let's get right to the command line where we can start covering some of these commands. Okay, so I'm here in my Ubuntu box, and I'm just in my home directory, and the first command we'll look at is pwd, which stands for present working directory, and it will just tell you what your current directory is on the system. Like if we were to go over to the etc folder and type pwd, it would just tell us that we are in the etc folder. All right. If we type cd, that stands for change directory. And if you type it on its own and press enter, it'll actually take you back to your home directory. And if we pwd, that's my home directory. It'll take us right back to there. All right, so we are in our home directory. Now, another command I want to show you, I'm just going to shotgun through all of these, is the touch command. Now, touch, if you touch an existing file, it will update metadata. However, if you touch a file that doesn't exist, like, actually, before I do touch, let's do ls. We've seen ls in other videos so far, but it's just to give a directory listing of what's in our current directory. If we do the -L flag, it'll give us in long form what's in here. And there's just one file that we can see, textfile.txt, and it shows that it is 12 bytes long. If we were to touch a new file, so touch file.txt, let's say, and now if we do ls-l, we're going to see we still have the file that was already in there, textfile.txt, but now we also have a file called file.txt, and it is 0 length. So it's not taking up any space in the hard drive. There's nothing in it. It's just an empty file. Okay, so that's one of the things we can do with the touch command. Now, if we want to make a directory, we would actually do mkdir for make directory, mkdir, and then what directory we want to call. So I'm going to say, well, stuff. We'll have a folder or a directory called stuff. And now if we do ls-l, we're going to see we have a folder here called stuff, and way over here in the permissions field, it actually starts with a D for directory. The dash here means that it's a regular file, and so that's right there. All right, we can then go into a folder with cd. So remember when we typed cd and then I typed a folder, we changed to that directory. So cd is change directory. So let's change directory to stuff. Okay, and now you'll see that we are in the stuff folder. And now really quickly, if you look down here, see how this kind of gives us the pwd, the present working directory? That is the tilde symbol. And if we were to say cd to tilde, tilde is just a shortcut for, I'm going to type pwd, it's just a shortcut for our home directory. So tilde, you can reference tilde, and that is just a way of saying the current user's home directory. So it's different for every user, but the S-Powers user, tilde is the same as home S-Powers. Hopefully that makes sense. Let's go back into the stuff folder, and I'm going to touch a file in here. So I'm going to say touch test file. All right, if we do ls, we're going to see now there's a file in there called test file. Okay, so let's go back now. Okay, I'll show you something in here really quick too. So ls-la A means show me everything, even hidden files. And the two hidden files I want to look at are the folder or the directory. See, it's a directory. It says back here directory. Just titled dot, and this one titled dot dot. And these are dynamic. So every directory that you're in will have these other directories listed. The dot, the single period, is just a way of saying current directory. So that's the current directory is the dot folder that you're in. Like you're in dot right now. So if I were to say cd to dot, it takes us right to the same folder that we're in. So see, we're in the stuff folder. Dot dot is the parent directory. So if I were to say cd dot dot, it will take us up a folder. And now pwd, we are in home s powers. If I were to do it again, cd dot dot, remember every directory has the dot and the dot dot in it. If I were to do that, now all of a sudden I'm in the home folder. So pwd shows us the present working directory is the home folder. All right, so I'm going to say cd. Now remember, I could just press enter to get back to my home directory, or I could do cd to tilde. Boom, and there I am in my home directory again. I'm going to make one more folder. So I'm going to say mkdir test folder or test directory. I use folder and directory interchangeably usually. And now if we do ls-l, we're going to see we're starting to get a pile of stuff in here, right? So let's say we wanted to remove a directory. Well, we know we can create a directory with mkdir, but if we want to remove it, it's rmdir. And so let's get rid of that test folder that we just did. So rmdir test folder, you can put the slash after it, or you don't have to, either way. And press enter, and now it's gone, ls-l. Okay, it's all gone. Let's try to do the same with the stuff folder and see what happens. He says ominously, rmdir stuff, it will not let me because it's not empty. And so that's like a safety feature of the rmdir, is that it will not remove a folder or a directory. It will not remove a directory if there's something in there. And if you remember, let's do an ls of the stuff folder. We created a file in there called test file. Now, there's a couple things that we could do to get rid of stuff in there. We could remove it. We could just say, I'll show you how to remove a file. We'll say rm file.txt. That will remove the file in my current directory. See, it's up here, file.txt. So if we do rm file.txt, and now if we do an ls-l, we'll see that file is gone. So we could do rm stuff test file, and it would remove it, and then we could run rmdir because the folder would be empty, and we could remove the stuff folder or directory. But there's another way. We could actually remove folders using the rm command if we go rm -r for recursive, and then if you don't want to get prompted for, like, are you sure? F for force. So rm -rf is like a super powerful way to destroy the whole world. Basically, every file that you have permission to delete, you can delete with rm -rf. It's a pretty scary file, or a pretty scary command. Anyway, we could do rm -rf stuff, and that's just going to remove it, including that test file that was inside. It just recursively removed everything in the stuff directory, which can be kind of scary. Now, did I cover everything? Let's see. mkdir, copy, rmdir, ... tilde, touch, cd. Yeah, I think I got everything covered, except, oh, I guess there's one more thing. And I think we looked at, I know we looked at this in the Linux Essentials course, but the tree command. So if you just type tree, it was listed here. It just shows you a thing. I'm going to quickly type, see if you can follow along and see what I'm doing. So I'm going to do mkdir test1, touch test1 file, mkdir test1 dir2, touch test1 dir2 file 1, touch test1 dir2 file 2. All right, so if we look in here now, we have this. But now, since I've done, like, I created a tree of files and folders, if you will. Now if we type tree, it's a little more interesting. If we type tree, we can see that it just gives us this really nice display of all the files and directories from where we are on out, right? So we could do, like, give me a tree of just test1, and then it would show us that, just that directory and all the stuff inside of it. recursively, and it's just a nice little ASCII format that shows us what it looks like. All right, let's clean up everything in here. rm minus rf star for like everything, star asterisk, there's a glob for everything. It'll just remove everything in this current directory. Scary, scary, but now everything is gone. All right, the other thing that we need to cover in this video is the concept of hard links and soft links. And soft links or symbolic links. I kind of like the idea of calling them symbolic links a little bit more, but you'll see them referred to as either soft links or symbolic links. And the difference is what it's actually doing. So a hard link is, first of all, let me take a step back. When a file is stored on a hard drive, like there's a name like this one, file.txt, and what this does is it points to a spot on the hard drive where the file lives, right? So this is like the first sector, and it probably goes a few sectors, and it points to that spot on the hard drive. So a file name is pointing to a spot on a hard drive. If you have a hard linked file, that means that you create another name or another link to the exact same spot on the hard drive. So when we talk about hard links, we're just talking about a file name that points to a hard drive, and you can have more than one file name pointing to the same file position on the hard drive. Okay, so in this case, file and file2 are the exact same file. They just have two different spots on the file system that point to the same spot on the actual hard drive. Now, a symbolic link or a soft link is different. Now, the original file, doc.txt, for example, is pointing to a spot on the hard drive where the file lives, right? The sectors on the hard drive are here. Doc.txt is pointing to this group of sectors on the hard drive. But a symbolic link, you have another file name, just like up there with the hard link, but instead of the file name pointing to that spot on the hard drive, it actually points to the file name in the file system. And so doc2.txt is pointing to doc.txt. It's not pointing to the hard drive. Hopefully that makes sense, because it is significant with how things happen on the system itself. Okay, so these are hard links, and this is a soft link or a symbolic link pointing to a file name. This is not pointing to the hard drive itself. It's just pointing to another file name on the file system. So let's create them both so we can see how they work and how they might affect things on a day-to-day operation of your system. All right, so I'm going to clear the screen here, and let's we're going to echo hello into file.txt. So we have a file there, and now let's just look at it real quick, I guess. So there's our file, file.txt. If I cat the file and look at the contents of it, it contains hello. I don't know if I mentioned cat earlier, but cat is how we look at the contents of a file. It actually is short for concatenate, which doesn't make necessarily a lot of sense when you're just looking at the contents of a file, but cat will show you the contents of a file. So cat file.txt shows us the contents are the text hello, all right? And then if we wanted to make a hard link, we would just do ln file.txt, and what was our example? I think file2.txt. All right, and now if we do ls-l, we're going to see both of these files are 6 bytes in length. Okay, if we were to cat file2, it's the same thing. And here's where it gets really cool. So let's say we were to edit. Now this is going to be another video, but I've used editing tools before, so just bear with me. If this doesn't make a lot of sense, we're going to explain it in the next video or two. Let's edit file.txt. I'm going to add a line, dude, for some reason. And I'm going to save that. And now if we were to look at file.txt, we would expect it to be hello dude, right? But if we look at file2.txt, it's also hello dude. Pretty neat, right? And if you remember, both of these file names are pointing to the same spot on the hard drive. So if we remove one, so rm file2.txt, all we've done is erased one of the links to that spot on the hard drive. Even though there's only file.txt here, if we look at it, it's still there. It's still perfectly fine because that spot on the hard drive is still in existence, and this one of the two links, we're still pointing to it. So a hard link creates a new file that points to the hard drive. But what if we were to do ln minus S for symbolic or soft. It's actually really nice that that works that way, whichever way you like to think of it. So instead of a hard link, we're going to do a symbolic with dash S, file 1, and we're going to name this one soft file.txt. Okay? And now if we do ls minus l, we're going to see something cool. What I really like is that when you do ls minus l, it shows you what it actually is doing. So we have our original file here. It is 11 bytes because remember we added the dude to it. So it's that original file. And now soft file.txt, they give you like this little arrow. It's pointing to file.txt. So it's actually showing you right here in the listing that it is a link that is pointing to the file here. It's not pointing to a spot on the hard drive. But for some things it works the same. For example, if we were to edit soft file.txt and we were to get rid of hello, so it just says dude. If we were to then look at the contents of file.txt, it's just dude because we edited that one file, right? Soft file is just pointing to file.txt. So when we edited soft file, we edited file.txt. But here's where things get really dicey or different. With a symbolic link or a soft link, if we were to get rid of file.txt, so rm file.txt, okay, it's gone. Now guess what? Now, okay, soft file is now doing what? It doesn't point to the hard drive, it points to file.txt, but we just removed that. Well, ls minus l shows us what happens here. It's like, okay, soft file is pointing to file.txt, but you'll notice it's all in red, and that's because it doesn't exist. And so if we try to look at it, so look at the contents of soft file.txt, and no such file or directory. I mean, the soft link is here, but the file that it actually references is gone. So that's the difference between a hard link and a soft link. And you'll find both of them in use, but it's kind of hard to identify a hard link unless you start looking at like specific inodes on the hard drive and stuff like that. But with a soft link, it shows you this really nice kind of like arrow, like, okay, this is just a link pointing to, you know, this thing over here. So that's actually a really nice thing about Bash, is that it shows you exactly what a soft link is doing. So let's build up a couple more things so I can show you the last two commands before we're done here. So I'm going to echo hello into file.txt, and this will actually fix our soft link too. Look at that. Now it's all better. Yay. Now if we were to cat soft link, it's going to cat it right out because sure enough, it's pointing to a file that does exist. And we're going to make a directory called folder and touch new file.txt and clear the screen. Okay, so if we do an ls, we have these folders. Let's do ls minus l. So this is what we have in there. And there's two commands that will give us some metadata on the individual files themselves. The first one is just going to be file. So the file command on file.txt. And this will tell us what kind of file it is. And so it's an ASCII text file. What if we were to look at folder? File of folder, it's going to say folder is a directory. Now, what would you expect new file to be? It's just an empty thing that I touched. Let's see. File, new file, empty. Okay, even though .txt is here, that doesn't really mean anything, right? We don't that's just like a convention. That's just like a standard operating procedure. It doesn't matter if it has .txt, that doesn't make it a text file. A text file or ASCII text, it's an ASCII text file if it has ASCII text in it, which this one did because remember we put the word hello in there. But since new file.txt has nothing in it, it's empty, it just says that it's an empty file. Okay, and then let's do one last one. We're going to do what kind of file is soft file.txt, and this will just tell us it's a symbolic link to file.txt. And so it just tells us what kind of directory entry, you know, whether it's a folder or a file or a symbolic link. So the file command just kind of gives us what that information is. Now the other one that gives us more information, I'm going to clear the screen again, ls minus l, is going to be the stat command. And this is like statistics, right? So stat of file.txt, and it will give us all sorts of information. Okay, it tells us the size, the name, the actual inode that it's stored on in the hard drive, that there's only one link to it, which, okay, let's do this real quick. So ln file.txt to file2.txt. Now I'm creating a hard link, right? So now if we were to say stat of file.txt, which is what we just did. So I'm looking at the stats on the same file. Now we're going to see there are 2 links to this inode on the hard drive. It can tell that just because there are 2 different links or file entries that point to the same spot in the hard drive. They have the same inode that they're pointing to. Anyway, these are other things that it tells us. The birth is when it was created, when it was changed. This means when permissions were changed or the metadata was changed on the file. Modify means when were the contents of it modified. And then access is when is the last time somebody looked inside of it. So if we were to do cat file2.txt, and we can see it has hello in it. Now if we do stat file2.txt, it's going to tell us that it was last accessed just now, right? Because that was the last thing we did is access it by looking into it. And if we made a change, modify would change. Okay, so that's what stat will do. It'll give you all sorts of information about it, including when it was created, when it was modified, when it was accessed, all of that really cool stuff, when the metadata of it was changed. And let's see what it will do with the actually, I don't remember. Let's do an ls-l. I kind of forgot the names of the files. Soft file, that was it. Okay, so let's do a stat on soft file and see what it tells us about that. It says that it's a file pointing to file.txt, and then it tells us when it was accessed and created and all that sort of stuff. But notice, even though it points to file.txt, it's giving us access information about the soft link itself. Because up here, we were looking at file.txt and it was last accessed at this time. But down here, it still has this older time, because although we accessed file.txt, we did not access the soft link that points to it. So this statistic, this stat command, is looking specifically at the symbolic link, not the actual file that it points to. Hopefully that makes sense. I honestly don't know what stat does to a folder. Let's look at a folder and see what it says. Oh, same thing. Okay. Yeah, it shows us all the same sort of stuff when it was modified, changed, etc., when it was created. But anyway, those are the commands that we needed to cover. Remember, these are just all the how to manage the command line system. And then we looked at stat and file, and of course, learn the difference between soft and hard links. That might have been really, really simplistic, and if so, I apologize. But if it was a little more complicated than you thought you were going to get into, again, be sure to check out that Linux Essentials course. It's a playlist on my YouTube channel, and it goes through all the basics so that you aren't overwhelmed by Linuxy things as we introduce them as this course goes on. Anyway, again, sorry for the week-long delay. Hopefully this was useful, and I look forward to the next video with you. Until next time, take it easy.